And over here, you can give birth to two babies, A horseshoe C and B horseshoe C. But to give birth, you either have to have a dot in the right-hand side or a wedge in the left. And sometimes you'll have to do this. So you just, when you need to do this on an exam, to do a problem, you can't write tip number 1. You need to actually go through the steps. So that's what we'll do. So we change the horseshoe into a wedge, and it's wedge over dot, so we can use distribution to distribute that. So notice we changed by distribution. We now have two wedges dotted together. And those wedges can be changed back into horseshoes. And then we just simp out. So that's how we do it. Notice, unlike real life, we can do something in logic we can't do in real life. Notice we went down, right? We went from here and gave birth to two babies.
Nice.
Mama horseshoe, baby horseshoe, baby horseshoe.
Where's Papa Horseshoe?
But all we have to do is take these two and conjoin them, and we get that, and then we can go back up to Mom. So we go backwards. The babies can become the mom. You can't do that in real life. Once you got the baby, you can't reverse the process.
Okay.
But you can in logic. You can reverse it and go back up to mom. So you can go from mom down to babies, and babies up to mom. And life's not like that, because life satisfies a thermodynamic law, the law of entropy, and logic doesn't. Well, actually, yes, logic, logic.
What about the Papa Horseshoe?
You lose information when you do things. When I simp, I lose information. I lose the information that this disturbed some people. Actually, it disturbed one person. He was a computer scientist at MIT. And he tried to create a logic in which you don't lose information. Losing information is actually, entropy. Information, the more information you have, the more order. And when you lose information, you open up, more possibilities. I'm sorry, you lose possibilities. And you lose more information that way. Well, anyway. So let's now give birth to this one. Okay, and notice here too, you can go backwards. Made a mistake?
Just for number 4, is that a horseshoe or is that a dot?
Line 4,
Yeah, on the left hand side.
on the left one or the middle one?
Left.
The left one, line 4. That's a dot here,
Okay.
yeah, and a horseshoe. Yeah, if that were a horseshoe, it would be a really tiny, tiny horseshoe, right? I mean, a mini, mini horseshoe.
What's the difference?
Of course, you know that, you're right, the horseshoes eventually become dots when they become so small, they're no longer horseshoes. So the evolution,
Horseshoes have evolutions.
so the dot can become, the horseshoe can become a dot. Well, the dot is satisfied with being just a small speck on the board, can become the big horseshoe. But I don't know if this is more interesting or important than just to be a speck on the board. If you were a speck on the board, or you were a horseshoe, how would you feel? These things can't answer. Unless you figure out how to get them to talk about themselves. And someone did in 1930. They found a way to get the symbols of logic, these symbols, to talk about themselves. And when they got them to talk, they were chatterboxes. And they said all sorts of things.
Like?
One of the things that they said was so impressive that many people took this to be the finest human thought of all time. But anyway, this was done in 1930. And if you take an advanced course in logic, you'll learn how to get these symbols to talk. And they will talk. What you have to do, actually, is assign numbers to them. And now that's a code. And then you have to learn how to read the code. Okay.
Dr. Cooper,
Yeah.
you said when you use sim, it uses content, but how did it use?
I said what?
You said it uses something, but what did it use? When you use sim,
I said you.
when you said you use, when you use sim, it uses.
Oh, yeah, we don't have to worry about that. But you lose information when you do proofs. And the question is,
Are you recording
can you
also?
avoid
So,
that?
you
So-
also recording?
That's,
You guys actually gonna
if you're
watch it?
interested, there's a famous paper.
On YouTube.
The guy who did work his name is Tommaso Tafali. He wrote a famous paper called Conservative Logic that appeared in a computer science journal in the early 80s. And he figured out how to get, this is a logic in which you don't lose information. Tips 3 and 4 will come in very handy later on tonight. If I remember, I may ask 2 bonus questions that will get you a free midterm.
Whoa.
Okay.
Before I get to tip 3 and 4, can you please go over one of the tip 1 or 2 one more time?
He can't hear you. Gotta speak louder.
Okay,
Can you read what that says?
yeah. Tip number 3 is, how do you prove a single atomic sentence when all you have are horseshoes, conditionals? And tip number 4 is, how do you prove a negated atomic sentence when all you have are horseshoes, conditionals? In other words, you want to prove A. Now, if you had A horseshoe, if you had B horseshoe A and B, you could do modus ponens to get A. But suppose you don't have any of the pieces. All you have are horseshoes, no pieces of the horseshoe. Then you can't do MP or MT. Well, here's the idea. If you want to prove an atomic sentence A, or a negated atomic sentence, squiggle A, find a horseshoe that looks like that. Once you get this, you can go up to A. So if all you've got are horseshoes, you probably have to do HS's, you know, get that, squiggle A, horseshoe A, and once you've got that, you're home. Similarly, to get a negated atomic sentence, get a horseshoe that looks like this. Get this horseshoe, and then you can get squiggle A. Now you're going to find problems where you have to do this. So it's important. So those are the 4 tips.
Very helpful.
And all of them will come in handy. Now, what I'm going to do is make up the midterm now. Make it up. So that I don't wind up doing midterm problems.
What does that say? Import? Oh, no, import, like line 2. Line 2, yeah.
Squiggle A, wedge, squiggle A. So when you imp this, you get squiggle A, wedge, squiggle A, right? Because when you imp, you change the horseshoe to a wedge, take the opposite of the left-hand side, keep the right the same. Okay. Okay, 6 problems. Okay. So, from exercise 4A, number 9, 11, 13, and from exercise 412, number 11, number 13, number 15. Okay, so those 6. They're due 1 week from tonight, when you come in. And the one thing I don't want to see is someone busily copying the midterm when I walk into the room from someone else's paper. If you're going to do that, do it in the afternoon. Don't do it while I walk in the room. Because if I see you doing it, you're going to get punished. Also, make sure you write down these problems. Now, I'm going to start doing problems from the book. I may become forgetful and forget what I wrote over there. I may erase what I have over there. If you see me start to do one of these problems and you don't say anything to me, you know, I will remember that I've done it after the fact.
You remember you did it last
So
semester?
you have to yell out to me if I start to do a problem that is a midterm problem. It's a midterm problem, don't do it.
How
What are
would we know?
benefits?
If no one corrects me, don't leave smiling thinking we pulled one over on them. Because I'll remember that I did that problem. And what I'll do is substitute for one of those problems for 4.8 or 4.12, the section I never assigned for exams, exercise 4.13. 4.13 are really hard problems. They're really long. Some of them take 30 steps. I never assign these for an exam because they're really super hard. We can do them if you want to do them
No,
in
we don't.
class, but you won't get them on exams. 4.12 is the intermediate level. 4.8 is our easiest. 4.12 are medium, and that's really pretty much. 4.13 are too tough. Even they say in the book, some of these proofs are difficult. They're all difficult for 4.13, so that's why you don't get them on exams. We may do some just for fun.
These tips that you illustrated, will they be, would we need to use them for this midterm exam?
Those 4 tips?
Yeah.
I guarantee at least one tip will be you'll have to use for this midterm.
Okay. Do you know which one?
I know, sure I
Okay.
do.
So could you maybe go over, because to be honest, I didn't quite understood what, how even to approach it. So are we giving something that we want to end up with? To,
Well,
like,
look.
purpose of this?
Look,
Like, for example, tip 2 or tip 1.
if you see one of these, or you see one of these,
What are these? What makes them these?
there'll probably be a need to give birth.
Okay, so when you're saying these, what makes them these?
What makes
These
them these?
versus
What makes them
those.
these is if you see a horseshoe with a dot in the right-hand side,
Okay,
or a horseshoe with a wedge in the left-hand side, you'll
Okay.
want to give birth.
got it.
And you may wind up, if you're faced with a problem where you've got to prove this, A, and all you have are horseshoes, you're going to have to get one that looks like that. Or if you're faced with a problem where you've got to prove that, and all you have are horseshoes, and you can't do MP or MT, you're going to have to get something that looks like that. I think we might, no, there's definitely at least one problem on the midterm that uses these tips.
Hmm.
I'll give you three opportunities tonight to not have to do the midterm. 3 bonus questions. Okay, so let's start doing these things.
This is when we're supposed to start recording. Bands to make a dance.
I didn't see the debate last night, but apparently nobody landed a knockout punch, according to the commentators, which means that, I mean, I wish the president had landed a knockout punch.
It was funny. He didn't.
What's that?
There was a comment where he told Romney, we have something called ships and aircraft carriers now. Did you watch the debate?
No, I didn't see it.
Oh,
I forgot it was on. I thought it was on tonight for some reason, because it's been on Tuesdays every, but I didn't realize it was on last night.
No, it was funny.
So, you know, they say there's 4 scenarios. There'll be a surge for the president, and he'll win the electoral college by 70. That's one. The other is it's going to be real close, and he'll win by 6. The other is Romney will win by 6. The fourth is it'll be a dead heat.
What's that?
Those are the 4 likely possibilities.
What was the fourth one?
What's that?
The last one?
A dead heat. They'll tie.
Oh.
And at the time, what happens?
Okay, so,
I can't get it.
I just came from a place this past weekend, UMass at Lowell, which was almost single-handedly destroyed by Romney in the 90s when he was governor of Massachusetts. He cut funding to the UMass system so radically that all the UMass colleges almost folded. He almost destroyed the whole system, but UMass at Lowell really got hit hard. And it wasn't until about 6 or 7 years ago that it started to rebound with a good chancellor, and now it's like booming. Like enrollment is huge, they're recruiting faculty, they have an inn on campus, right on the river, because Lowell was built, it was an old mill town built on a river. So, good place for a conference. Okay, I did a couple of 4.8s last week. Does anyone remember how many we did?
Which ones you?
From exercise set 4.8. Does anyone remember which one we got up to? Does anyone have the proofs from last week?
I do have them, but I'm looking. It's very disorganized, so unfortunately.
Oh, you haven't written down.
Yeah, we did 7, 9, 11, 13, 13.
You did which one?
7, 9, 11, 13,
I did 7, 9, 11, and 13 last week.
and 15.
And 15? Oh, geez, they're all on the midterm. 9, 11, I did 9, 11, and 13 already? And 15?
I believe it's from 412.
Or maybe it was from 4-6.
Yeah, I don't know.
Yes, 4-6. It was from 4-6.
4-6 or 4-7.
It was 4-6.
You got the fun.
Yeah, I believe from 4-8.
Yeah, from 4-8, which ones did I do?
Don't look it up.
I thought I was just doing the odd numbers last week.
Did 1, 2, 3.
Oh, can I take a look at that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122 Okay, did you turn that page? Okay, did I do these?
You did these, but I don't think it's from 4-8.
I did what?
You did these, but I don't know if it's from 4-8.
Oh, no, these are for 4-5.
Ben's Jamaica dance.
Okay, excellent, thank you.
Huh?
Good, so we're all set. So I went up
What
to
email?
5. Okay, that's good.
Oh, I did send it. I didn't get it. I didn't get it. Oh. See, I'm out the loop. I didn't get it.
Okay, you see F in there? Squiggle F?
No.
You see F?
Yes.
Yeah.
What line?
1.
In a? What side?
Empty,
MT,
empty.
MT, MT. What do we need to do MT besides this? Do you see squiggle G in here?
No.
You see G?
Yeah.
And the dot's in a. So we're gonna have to drive this in. A useful tip is when you can De Morgan something in. If you can drive in a squiggle by De Morganing it, do it. That's a useful tip. Whenever you start your proof off, De Morgan the thing.
The Morgan.
Now remember, we were looking for squiggle G, and there it appears, right there. It's in a what? DS, DS. What else do I need to do DS?
Me.
There it is. So I can do DS. And now I can do MT. Okay? Okay, so once again, De Morgan this guy, right up, before you do anything, just De Morgan it. Okay, now take a look at what you want to prove. Do you see M among your premises?
No.
As soon as you make that observation, the light should go on in your head, add. You're going to have to add M. So you want to know what you have to add M to. And to figure that out, do an M on this. So we're going to have to add M to squiggle L. And that's what we need to get, squiggle L.
Why
You
to
see squiggle L in here.
I'm sorry, why to squiggle L? Why do we need to add M to?